All right, skipped. Number 9, we want to write a polynomial of degree 3 with zeros 3, -4, and 5. So usually when we solve, these are our x-intercepts, so we say x equals 3, x equals -4, and x equals 5. We're going to write these as linear terms by setting them equal to 0. So if I move this over, this gives me x minus 3. If I move this over, adding 4, this will give me x plus 4. And if I subtract this over, this will give me x minus 5. Now at this point, all I have to do is multiply this together and I get a polynomial. Sometimes you might have a coefficient out front, so I can write really any number I want to out here, and I can get multiple polynomials that will have these 3 as zeros. So just for example, if I FOIL this out, x times x will give me x squared, x times 4, positive 4x, 3 times x, negative 3x, and then negative 3 times 4, negative 12. Alright, so this will give me x squared plus x minus 12. And then I'm going to add the x minus 5 to the mix. So I'm going to distribute everything times x and then everything times 5. So x squared times x cubed, x times x squared, and then negative 12 times x, negative 12x. Alright, now times 5. X squared, negative 5, negative 5x squared. Line it up with the like term. X times negative 5, negative 5x, and then negative 12 times negative 5, positive 60. So we get x cubed minus 4x squared minus 17x plus 60. So this is one such answer. If I wanted to, I can multiply this by 2 or 3 or just put any coefficient out front. The zeros will stay the same and I'll just get a new polynomial. So just leaving it in the basic form will be sufficient. So let's say x to the third minus 4x squared minus 17x plus 16. Given conditions, degree 3 with zeros 3, -4, and 5. Unless we've made some kind of error, we should be good. Let me double check everything one more time. X squared, 4x minus 3 minus 12. That gives me that. And then x minus 5. So we'll do x cubed, x squared, and then plus or minus 12x, that's right. So all of these times x. And then minus 5x squared minus 5x plus 60. I'll put plus 16. No wonder. I don't know why I got 16 instead of 60. Okay, I just made a mistake here. I wrote down 16 instead of 60. All right. And then number 10, we're going to use the factor theorem to determine if the binomial, given binomial is a factor. So the factor theorem is basically using synthetic division, and when we get to the end, if the remainder is 0, it's a factor. If the remainder is something other than 0, it's not a factor. So we have x to the 4th mouse is kind of in the way, minus 2401. And we'll just use the factor theorem to see. Now this probably does factor difference of squares. We can apply and kind of see that I believe they both will be, but we'll do synthetic division. So we have an x to the fourth. We're going to have two terms. From the x minus 7, when we set that equal to 0, we get x equals 7. And then from the x plus 7, set that equal to 0, we'll get x equals negative 7. So these will be the two numbers we use. So I'm going to do the positive 7 first. We have an x to the fourth, coefficient of a 1. X to the third, 0, x squared, 0, single x, 0, and then this single term, negative 2401. Bring down the 1, 7 times 1, 7. Add, we get 7, 7 times 7, 49. Get 49, 7 times 49. It's 243. Let me double check. I believe that's 243. Basically 7 to the third. 343. Gotta be careful. 343. And they'll give us 343. And then when we do 343 times 7, basically 7 to the fourth. That gives us 2401. And then that gives us 0. So, yes, the x minus 7 is a factor. Do the same thing with the negative 7. 1, 0, 0, 0, negative 2401. Very important, you got to put those zeros as placeholders. If not, it will not come out correct. Calculator is in the way. Okay. Negative 7 times 1, negative 7. And negative 7. Negative 7 times negative 7, positive 49. Negative 7 times positive 49, negative 343. And then negative 7 times negative 343, positive 2401. And we get 0. So both of them come out to 0 as a remainder, which means they divide evenly and they both are factors. So we'll say x minus 7 is a factor and x plus 7 is also a factor.